All right. Hello, everyone. Thanks for joining today. Today's webinar is end-to-end security in a web application. This session will focus on how authentication, authorization, and security requirements can be implemented in ASP.NET Core. My name is Manish Kapoor, and I'm your moderator for today's webinar. This webinar will be presented by Damien Bowden and Denis Troller. So before we begin, let me go through some housekeeping essentials. This session will be about 45 minutes with a Q&A towards the end. You are invited to submit your questions via the Q&A box in Zoom, not the chat box. Our panelists today are Andre Pure and Jolt Kolbe. They will monitor and answer your questions as they come in. They will answer as many questions as possible during the live webinar. This session will be recorded, and we will send you a link with the recording in the upcoming days. Finally, at the end of the webinar, there will be a short survey that will pop up on your screen. It will be very nice of you if you can submit that survey. We consider feedback to be a gift. Thanks in advance for your participation. So let's let me introduce the speakers for today's webinar. We have a special guest, Damien Bowden, who's a web developer at iSolutions in Switzerland. And he's also a Microsoft MVP who will be delivering this webinar alongside our product manager, Denis Troller from Sonar. So thank you for delivering this webinar, Damien and Denis. They will answer your questions also at the end of this webinar that we want to cover, which we couldn't answer during in the chat panel. This session will be recorded, and we'll send out a link again in the upcoming days. So without any let me pass it on to our speaker today, Damien Bowden, to kick off the webinar for today. Thanks, Damien. Over to you.
Okay, thanks for the introduction. I'll just share my screen now. The screen. So I just put up the whole agenda on GitHub, and what I thought I'd do is I just explain what I recommend implementing end-to-end security in a web application by just actually creating a application which I think could be used in production. But of course, there's many different ways of doing this and many different forms. So, and then I'll explain different things, maybe how you could do the authentication, what's best practice or what's recommended, how Microsoft Entra ID could implement this, a small bit about session protection, and then of course then how to implement the CI/CD, the build, and so on. So the application itself, there's been a big change lately how you implement security at the moment, and in the last couple of years we've been switching and doing single page applications with backends. They're nearly always implemented with different technical stacks. So what happened also with the splitting the technical stacks is that we split the security as well, which was a bad idea because we're securing sensitive information in the browsers. And what's happened now is that we deploy the two as one now is the new recommendation. So all web applications is recommended that we secure them as a single security context, and we use a secret, or we validate the application as well as the user authenticating. So what we do nowadays, or what's recommended for some setups, is that we deploy them as one and we secure them as one. So this works fairly good, but one of the problems we have is that when we're setting these things up for local development, a Angular development, for example, does not want to be using .NET Core tools, or a .NET Core developer does not want to be using Angular tools. So for local development, we need to split them and let the developers or the architects use the tools that they know and want to use, because then they're the most productive. But when we deploy it, then we have to build them together and deploy it as one. So the Angular application is no longer a standalone application. I'm using Angular 18 in this example with NX. It's actually part of the backend. So you can see it as a UI view of the backend application, which is a .NET Core application. And they work as one together. And we secure the whole thing as a OpenID Connect code flow confidential client with Pixie then is what's recommended now usually. Now, I could also implement this as a standalone application, which doesn't connect to any other OpenID Connect server. It's completely standalone. But that's not really recommended anymore for enterprise deployments, or it's actually you're introducing more complexity as you're actually reducing. So I always try to use existing identity providers or systems, especially in enterprise world, where nearly any company I work with or any deployment, they already have an identity provider somewhere, and I just try to reuse whatever the company is using, and then I use OpenID Connect to connect into that. Then, so in this setup, maybe I'll just show you. I use a proxy to separate the Angular development to the .NET backend, and then you can use your own tools. So that's really important that you need a local setup and development, that you need to have a production setup, but you want to keep the two of them as close as possible. So, for example, I always use HTTPS everywhere, so I can use the same type of session protection on my local development as on my deployment, and that saves an awful lot of effort after I do deployments. So, looking at the authentication flows, the recommended flow nowadays would be OpenID Connect code flow with Pixie and with a confidential client. So just to show how this works is, this is the flow without the Pixie. It's a two-step authentication flow. So what happens is that when the browser is open, you want to authenticate the application, you redirect the whole application to the server. And this could be Entra ID, it could be Auth0, it could be any identity provider. If all the parameters are correct, then you can log in, do your authentication, do your multi-factor authentication, use your phishing-resistant authentication like passkeys or FIDO2. Then you give your consent. If all is okay, you get redirected back to the UI in the browser with a code. Now, this code comes back in the front channel in the browser, and then the code is taken, and in the back end of the application, it's sent then with the secret, or if you're using certificate authentication, you send the client's assertion to the server, and then you get your tokens back. You get ID token, a access token, and maybe a refresh token back, depending on what you requested. Now, there's different flavors and flows and variants of this. For example, you're meant to keep the ID tokens really small if possible, because you need that to log out usually. So if I'm doing that, I'd probably use a user info endpoint, and then there'd be an extra step at the end. Or sometimes you can make it a 3-step authentication with PAR, a new RFC that's just come out. Or you could use MTLS to strengthen security. There's different ways of changing and improving this, but at the end of the day, it's always OpenID Connect code flow with Pixie, and I validate the application as well as the user authenticating using the application. So I mentioned Pixie a few times. So what is Pixie? Pixie is used anytime you use code flow. So you should never use OpenID Connect code flow without Pixie. It's required everywhere now. That's the recommendation. So what is it? It's actually really simple. I took this from the RFC itself. All you're trying to do is make sure that the application that sent the first request is the same application that sends the second request. It's a two-step authentication. So it's actually very simple to implement this. All you do is create some random string, you hash it using a one-way encryption, and you send that to the server. The server saves this. And on the second request, where you send the code, you also send a code verifier, which is the original string. The server hashes that using the same encryption and validates that the two hashes are the same. And then you know that the application that sent the first request is the same as the application that sent the second request. And with that, then you can prevent people robbing the code or taking over, hijacking the session. So that's authentication. Now, if I was implementing this with Microsoft Entra ID, I'd be using Microsoft Identity Web, and every single identity provider has its own little flavor of OpenID Connect. So the problem is that if you're using Keycloak or you're using Auth0 or you use any of them, they all have slight differences in the flavors. So nearly all of them produce their own clients. And all the clients are is wrappers around the OpenID Connect. So you can implement any OpenID Connect client using the original defaults OpenID Connect implementation for ASP.NET Core. But you can also use the client libraries, which is just a wrapper. So for example, Microsoft's wrapper is called Microsoft Identity Web. And with this, then all you need to do to implement the whole application is 4 lines of code. So this is just implementing the flow I showed you in the previous screen. What it does is it sets up the OpenID Connect code flow with confidential client. It's recommended to use client certificates. So it does a client assertion and not a shared secret to do the second call. You have to enable the downstream API to make sure that you're using code flow with Pixie and not implicit flow with confidential client. It's just a Microsoft thing. And then, of course, if I'm getting profile data, I'm using X strings, I'm using delegate calls to the Microsoft Graph API as well. A special thing here is that you have to use a type of token cache, because I use in-memory mostly to test. And what happens if you restart the application, you lose your tokens, and then you still have your cookie, and then you get funny errors by deployment sometimes by restarting the application. So you have to use a proper cache, or you have to delete the cookies if you don't have correct tokens. But other than that, it's basic, exactly like before. Now, if I was implementing this with Keycloak or any other server, if I've only got a single OpenID Connect client in my application, I'd always try to use the default recommendation from whatever IDP you're using. But as soon as you go to multiple IDPs in one application, or it gets a bit more complicated, you always have to revert back to the default OpenID Connect. Otherwise, you get yourself into trouble really fast. So, yeah, that's my recommendation, that always use the client from whatever IDP you're using. But as soon as things get complicated or whatever, then you have to default to the default what Microsoft delivers. Then. Okay. The next little thing I'd like to talk about is session protection. So the authentication IDP and the authentication, that's only for setting up the session and also for logging out. We have standards and RFCs for that, and you should always stick to the standards, and you should never try to roll out your own auth. Reuse one of the whatever's provided by or whatever you can use. Never try to do it yourself. Just try to reuse something that exists already. But in between the authentication at the start or the logout or the sign out at the end, you need to protect the session. Now, the recommendation is that we're using cookies at the moment. So if you're using cookies, you have to add in some extra protections, because, for example, you need to make sure that you're not open to cross-site request forgery attacks, or you're not open to cross-origin request site attacks. So it's really important that you add in the extra protection, and there's a load of different tools and different ways of protecting the session. So you have to make sure that your cookie's protected, a HTTP only, same site only cookie. And then you have to make sure you have some type of anti-forgery cookie protection, or you're using a custom header which is validated in the back end to make sure that you're not open to open cross-origin attacks. And of course, then you've got a load of security headers in all the browsers which are supported, and you can just add in the security headers to all your responses that comes from the server. So what I usually do is I use a library from Andrew Locke to implement security headers. I think that has everything in one stop. And you find these in the Netscape security headers is what I recommend. It's the easy way. Now, the problem with security headers and the setup for the session protection is that every single tech stack has a different settings. Some are better, some are worse. So if you want to get really good session protection, CSP nonces is a must, and you should be using CSP nonces. Not all technical stacks support that. I used Angler because Angler can actually has full support for CSP nonces in the provider side, Angler 17. So if I send the nonce from the back end to the front end, I can add that to the Angler providers, and then they'll add it to all the generated JavaScript for the modules or whatever they're creating. So Angler is actually really well and really good at protecting the session, whereas other frameworks don't support CSP nonces. So I try to avoid technical stacks that don't actually support CSP nonce now. Then after session protection, so you have authentication, you have to sign out, you have session. Then you also need to protect the build and the setup. So you have continuous integration, continuous development. So one of the main things here is that you have to say, I automate everything from A to Z. The more automation you have, the better you can reproduce things, and the easier it is to deploy it, and the easier it is to validate errors. For example, if I'm need to rotate secrets and it's not automated in my deployment, you don't want to be doing this from hand. You want to do this automatically, and you want to rotate the deployments maybe on every release build or whatever. So a typical CI/CD, I use Azure DevOps, or I use GitHub and GitHub Actions. I use some other ones as well, but they're the two I prefer the most. Normally, what I try to do is I have an automatic build, I have an automatic quality build, and then I have an automatic deployment or the deployment build. And then, of course, I have the build for the infrastructure as well. So I try to build the whole infrastructure from deploying to AWS or deploying to Azure, and things like Terraform or Biceps will be usually deploying to Azure. And then if I need to reproduce a dev test prod environment, or I want to rebuild it to delete the whole tenant and then deploy it again, I can set up the whole thing as infrastructure. That's usually something that you only do once or twice, but it's really useful if you need to reset or redeploy or change your environment. Then, of course, the development build or deployment builds, I do them on every pull request. Maybe there's different ways of implementing your Git flows or whatever. But I try to automate the whole thing, which is most important. And then, of course, the quality build, I try to use always Sonar Cloud. And when I use Sonar Cloud as well for the quality build, I try to analyze the code and have SAST tools now in Sonar Cloud, which is available. But it's slightly complicated when you're using different tech stacks. The problem is that it's not so easy to, it is actually when you know how, but you need to reference one project from the other project to be able to do the Sonar analysis in two different tech stacks. So in this setup, I'm using Angular and I'm using .NET backend. So I'm analyzing for .NET in the build, and then I have to link in the Angular tech stack so that we get the analysis in the Angular files as well as the .NET. So it's a little bit hacky, but what you have to do is in your .NET projects, if you want to analyze two tech stacks using Sonar Cloud, you have to reference the Angular project, the TS and the JS files, but just not use them. So I reference them, but I don't show them. I use them anywhere in the project. And with this reference, then Sonar can then analyze both the Angular files and the .NET files. So when I show them in the UI then, using GitHub is actually really good integration using Sonar. I can add the badges then, and I can link then directly into my results from Sonar, whatever I'm using it, and so on. Another little thing that's really handy, I think, is that if I have security issues or problems, they will directly be displayed in my Git repo to saying you have a security problem, just like any other SaaS tools, and then you have security warnings here saying you need to fix this, this, and this in your application. So I think this is a really easy and good setup for, I think, with the maximum possible security web applications. And then you have great tools to analyze as well. Maybe you want to say something to that, Denis, do you?
Well, I do have one or two questions for you.
Yeah.
Thanks for the presentation first. You mentioned that you're using Angular 17 because it supports nonce,
Yeah.
CSP. And do you know of any other front-end library that would be applicable? I'm thinking mainly React being the other big one. Is there any version that works?
I haven't seen any React using a CSP nonces are easy to integrate. So what we do in a lot of CSP React applications, either we create a local index file, we add the nonce to that, and then we use it for the base files, and then we have to add in hashes as well. But there's no direct integration for CSP nonces in React. If I'm using Blazor server, you can use CSP nonces. If I'm using Blazor WebAssembly, I cannot use nonces. So I tend to use Blazor server with the new .NET versions only at the moment now, because you don't have support for CSP nonces in Blazor WebAssembly.
Okay.
So, and Vue.js, as far as the last time I checked, it doesn't support CSP nonces. And I think that's the big four UI frameworks that I use.
It can make sense. And you quickly went over the authentication part and using OpenID.
Mm-hmm.
Maybe you want to explain a bit more what an IDP is, because maybe not everyone is fully aware of what that means when you're doing web development today. Because in the old days, you would use whatever solution Microsoft provided with you, and you would basically deal with your whole system inside your app. And what happens today is that the landscape is a bit different.
Yeah. Okay, so IDP is identity provider, and in an enterprise scenario, this is really important. There's almost no companies that doesn't have its own identity provider. So a typical company uses Office 365. That's the big enterprise provider in the enterprise world. So if I was making an application, I don't want to be managing and adding users, removing users, making sure the user are no longer valid, making sure that the data is correct. When they get married, you have to change the emails, updating. I don't want to be doing all that stuff. So why do it twice when you already could just reuse that type of implementation from the company? Because the company already has this onboard and offboard for identities, account management, and all that stuff. And then second of all, when I implement my own identity solution, I also have to implement my own security. So if I'm using ASP.NET Identity, it's a very good solution as well. I also need to keep it up to date, and there's always new attacks happening, new problems happening. I have to make sure I'm using recommended best practice. For example, the latest ASP.NET Identity doesn't support passkeys or FIDO2 keys, whereas nearly all the other identity providers which support OpenID Connect or SAML do support it. So if I was using Entra ID, I get passkeys and FIDO2 keys out the box, whereas you do not get that with ASP.NET Identity, and I do not need to manage it. if you're using passwords, what happens if people forget the passwords? You have to implement your own password management policy where you can just reuse the company ones if you're using a company. Then if I make an application where I'm deploying it to multiple scenarios, I don't want to create a new authentication identity solution for every single deployment. I can just say, here's my OpenID Connect, you take care of the rest. That's where you're the expert. So I always try to focus on that. I want to remove and do as little as possible with that so I can focus on the business. So the easiest and least complex way of doing it is to actually use OpenID Connect and not roll out your own auth. And people seem to think it's quicker and easier to do username, password, and log in. And it starts off really fast, and you get your cookie back. Everything's gone well, but once your application gets successful, then you have to start actually managing users and rotating and updating them. Then you get into a massive problems, or when you have to deploy it to a new company, a lot of enterprises will not allow you to roll out your application now if you're not using a proper authentication. So if you come with your own authentication system and you want to connect into my enterprise, especially if I'm a big enterprise, I will say you're not allowed to connect the app. You have to either use SAML or OpenID Connect. There are standards now. So it's the easiest and the best way forward if you want to make your application reusable and the most secure. And that's why rolling out your own auth should be always, for me, the last resort. Even if you do it well, you're making more problems than you're actually saving. Now, there's other scenarios. For example, if you're in the business to consumer market, you have to implement your own auth because you don't know your clients, they're coming from different places. So you have really great solutions for that as well. For example, Auth0 is a really good B2C product, or you can use your own system if you need to. For example, Identity Server or OpenID Connect if you want to roll that out yourself. And then you have full control and customization for that. It depends, of course, where you're deploying and what you're building. But you have to try and choose the one with the least effort and least maintenance. And if you do go the own way, then you have to keep up the modern standards and modern recommendations. For example, username password is something that should be no longer pushed or used. And we still see new applications implementing with username password, which is not recommended, or this would be really avoided. And this is one of the typical security holes. You have a single factor authentication and you're handling maybe finance data or you're handling health data. So it's totally wrong. And these are the things that we have to, as developers, move away from. So we should be choosing an architecture which allows us to implement the best possible authentication and best possible application security. And usually that means just don't implement yourself, but delegate that to an identity provider. Does that help?
Yes, I must say I fully agree with that. Having tried to implement such a thing, I quickly realized that the best idea was not to do it because it can get hairy very quickly.
Yeah.
So,
and maybe that's another problem. People think OpenID Connect and OAuth 2 is really complicated. Maybe the problem is that we don't have good documentation because each solution only documents their own solution and they don't actually share the shared solutions. But at the end of the day, if we're doing a web application, it's pretty simple now. You just use OpenID Connect confidential client, and then you try to connect to any IDP. It doesn't matter which one, and then follow their recommendations, and it should be fairly simple. So the authentication part is easy. The session protection is also fairly simple. The authorization is always difficult because that's always application specific, and there's 1,000 ways of solving this. And how do you log out? Are you dynamic or static authorization? It's not ever difficult, and it's every new application has its own authorization problem, and it has its own authorization business logic, which is different. So authorization is never easy to solve. The others are, if you're using the right tools and the right mindset.
all right. Do you? Another question is, so you mentioned you use Sonar Cloud, so thank you for that. Do you have any kind of specific flow you follow when you use Sonar Cloud?
Okay, so we try to use it really early in our development. So anytime we have a new application, depends on the application. Sonar Cloud is not in my country hosted. So the first thing we have to make sure is that we're actually allowed to use the client data and put it onto Sonar Cloud. So the first flow we have is to decide if we're allowed to use Sonar Cloud or Sonar Cube. And these are two different types of things we've decided, because if we're doing a high security application where the data is not allowed to leave the country, or we have to get the permission of the client and they don't actually allow that, that's the first decision we make. Sonar Cloud, always if possible, because then we don't have to manage it and look after ourselves. Otherwise, we can use Sonar Cube. After that, then what we try to do is we try to build in the quality build as early as possible. But sometimes the quality build takes long. We don't want to be for every little commit, every little push, be running this quality build the whole time. If you have a big project, it can maybe take up to 10 minutes sometimes. And you don't want to wait for 10 minutes on every commit. Otherwise, you stop checking it. So we try to optimize. There's no proper answer to that either. We try to use it as much as possible, but we need to keep the build times really short. Before we merge, usually we have dev, test, prod, sometimes integration. Anytime we're making a release to we always run the complete code analysis and the Sonar cloud analysis before actually releasing. So I think this is great quality control, and it's the quality of the code controls that we get out of it is really high quality, and this saves us loads of time as well. So I'm doing a lot of marketing for you here. I think it's an excellent tool.
And
fully integrated in the build, then that's the main thing. Everything has to be automated. That's the golden rule.
Yeah, I again agree. Build, deployment, quality control. If it's not automated, very soon you will not do it. Yeah. So it needs to be transparent and painless. Otherwise, nobody follows it.
Yeah. Another thing we do is with the secrets then is for example, when we're doing local development, we try to have as little as possible cloud dependencies. So all our secrets we save into the user profile using user secrets from Visual Studio or from the .NET tools. And only when we deploy it to deployments do we actually start using Azure Key Vault or cloud service to store the secrets. So we have no secrets anyway inside the builds. And then with the Azure DevOps or with the GitHub Actions, then there's different strategies of how to actually implement the secrets for the build pipelines or the resource or the deployments and so on. But I think it works out. All of them fit in well together. You can see that they work together, different tools, and it doesn't matter if you're using GitHub Actions now or you're using Azure DevOps. They all work well with all these different tools, I think.
And from your experience, which part of all that you've presented do most developers have problem with? Like, what's the biggest issue you encounter as far as understanding or
I think
in terms of security?
Authentication, which flow to use where, is always the same. So you get an awful lot of architects. They try to build the architecture and they design it. They have the different patterns, or they start doing this. They say, I want to do containers, I want to use this tool, I want to use this. And then they try to add the security at the end. And that's where they all crash, because then they're trying to fix it at the end or try to fit it in. And they should be doing, as part of the architecture from the start, they should be also doing the security context and the security architecture at the same time. So if they start splitting up applications into microservices, or they start splitting it out into different UIs, they're all completely separate applications, and you have to start solving problems like downstream API access. You have to do single sign-on, and your security gets really complicated, and you have a fairly complicated security setup then. Whereas you keep it simple, and you only have maybe one web UI, and you don't have separated web UIs within the UI, your security context is much simpler. So you need to have an architect that's security at the same time as doing the architecture from the application. I think that's where most people fail. It's the decisions that are made at the start is what makes it really hard to secure at the end. Or for example, you start doing some type of container deployments. You have to build everything locally using HTTP, because you don't have the time or the knowledge how to build it up locally using HTTPS. You deploy it, you're still using HTTP on your deployments, and then you have problems with security because you have no security if you're using HTTP and not HTTPS. And then suddenly you have to start building in things to add in the HTTPS between the different connections, and then you have to add in the security headers between every connection. You have to decide if you're using API to API or using delegated or authorization flows. It gets really complicated as soon as you start splitting it. So I always say keep it simple and don't split unless you really need to. And when you're splitting it, then start planning the authentication. And then of course, should I use tokens or should I implement my yachts? For example, I see people implementing JWTs and creating the JWTs themselves in code from a username password flow. And that's always wrong. You should never do that because you're open to so many different types of attacks, which is always going to get you later down the path. If you ever do a pen test, you'll fail it, for example, because you're open to impersonation, you're open to asymmetric keys should not be used anyway for JWTs. There's so many things goes wrong with that type of approach. And then if you just read up and you followed one of the guidelines from the big service providers that actually deliver that, the documentation for each of the identity providers or secure token servers or the products that actually implement this, they recommend best practice usually pretty up to date. So, for example, at the moment there's a new best practice coming out called best practice for browser-based applications, which is pretty much the same stuff as I'm saying with more technical language. Recommend the backend for front end and so on, but they recommend pretty much everything you should be doing nowadays, and it keeps getting updated or changed. And if you look at then at what Ping Identity or Okta or Microsoft Entra ID recommend, you'll see them almost parallel what they recommend. Or you look at the identity server documentation, the best practice recommendations are nearly always up to date there. And if you follow what they're documenting, you're moving in the right direction. That's why I always OpenID Connect. I never recommend SAML anymore as well, not because SAML is not good. It's because it's just too complicated and you can run into troubles really fast if you start using SAML. That's why it's much easier to implement OpenID Connect at the moment and not SAML. That's why I always try to choose the most simple solution using what's recommended in best practice.
Okay. Well, thank you very much for all that. I think it's going to be time to move on to some housekeeping and some Q&A. Before that, do you have any last words? What's next for you?
Okay, so I do teach this as well and show people how to implement this as well. Anything I make or try, I always put up on my GitHub repos. So if people have questions after this or want to get back through me in different channels or through Sonar, doesn't matter. You'll find nearly everything I document on GitHub, and I always try to update and keep the best practice recommended. I always do new templates and new demos how to do this. Just check out my GitHub repos as well, or ping me directly as well. You find everything online anywhere on GitHub, especially the new specifications and standards which are coming.
Okay, well, thank you very much.
Thanks.
And with that, I think, Manish, it's back to you.
All right. Can you see my screen, Damien and Dennis?
Not yet, it's black.
Not yet, but it's coming.
Not yet. Let me try it one more time. It's working?
Yes.
Yeah.
Okay. Here I am in 2024 trying to figure out how Zoom sharing works. Sorry about that mishap. But thank you, Damien and Dennis. That was great content. I appreciate, Damien, you taking the time and joining us as a guest speaker here in this our monthly webinar. We have had some questions, and thank you to our panelists for answering those questions on the fly. As we gather some more questions to answer them live in the next couple of minutes, I do want to basically, invite you to answer the next short poll that will be appearing on your screen shortly after this presentation, and tell us whether you would like us to be contacted to learn more about the product pricing, etc. And then also want to invite you to join our next 2 upcoming webinars in the month of June. The first one is everything you need to know about SonarQube. I did see some SonarQube questions come in, so that would be another good avenue for you to learn more about SonarQube and understand what that product does. And then we also have a dedicated session for federal agencies coming up in June, which although it says it's for federal agencies, but I personally think it will be beneficial for anybody who has some strict governance and compliance requirements. So if you would like to know more about how we help in those environments and for those customers, that webinar is on June 13th, and that will be beneficial for you. All right, should we take some questions?
Yeah, go.
Are you ready for it, Damien? So why do you recommend a backend or front-end architecture, a BFF architecture?
Okay, so the problem is that before, when we had this technology split between when people start doing user interfaces using JavaScript technologies like Angular, React, or Vue.js, or whatever you're using, we had a split between the applications, and then we start securing the SPA applications in the front end in your browsers, and then we had a back end where we did the API calls in the business. And the problem was that we are using OpenID Connect to authenticate the applications, but we're storing the tokens and the sensitive data that we people try to rob in the browser. So it's either in your local storage or your session storage, or you're using maybe a web worker which is accessible from JavaScript. And the problem is that it's impossible to prevent an XSS attack. There'll be always a new way of doing XSS. And if I have sensitive data stored in the browser, it's easier to rob that. And by implementing the backend for front end, we've actually removed the attack surface because there's less to rob in the browser. You can still take over the session, but there's no tokens to rob, which I can start using that against the API now. The cookie has its own browser protections, and it's much harder to rob. If you implement your cookie protection properly, it's easier to secure it as when you're using JWT tokens, which a single page application, which stores these tokens in the browser. So there's less to rob, and it's easy to implement. So the backend for front end architecture, what it does is it says every UI now is a confidential client. And with this type of setup, the standard setup that most people do is they don't actually implement the business logic in the same place as the front end UI application. They just implement the layer, which is the confidential client for the security. All the security is moved into this BFF, the backend. And then all it does is proxies the request from this UI part of the application, the Angular, React, or Vue, and sends it through the backend to whatever downstream API using some type of proxy. So it comes in with a cookie to my backend. It cannot access anything cross domain, cross site. Everything is blocked except exactly the same domain, same origin. And then from there, you go through the proxy, and then you can use anything you want after that. You can use a certificate, an access token, application access token. There's so many different things you can use between API to API security. But behind that, then you get proxy, you get the data from whatever business is, and then you can bring it back. Now, you don't have to use backend for front end. What I set up here is without the backend for front end, I have the business logic directly in the backend. So you don't actually need to make the second hop, and then the performance is almost as good. The only difference in performance is I'm using a cookie instead of a JWT, but it's still only one hop, and you don't usually notice that anyway, because if you're doing database requests anyway, that's the slowest in the whole chain. So I don't see any performance problems with that either, to be honest. So it's more secure. It's harder to rob stuff. It's not perfect, of course. Nothing is ever perfect, but it's now the recommended way of doing security. So when you put it really short, everything is a confidential client. Every UI has a backend somewhere which is used for security.
Okay. Thanks, Damien. I do have a couple of more questions, and we are, coming up to the time. We have about 6 minutes left. But I will go through the questions here quickly. What's the best way to handle unit and integration tests for an authenticated application as part of the CI/CD pipeline run?
Okay, so for unit tests, that's easy. You're testing directly against the application. You have no security involved in it. There's no problem with that. For integration tests, for APIs, it's slightly more difficult depending on what type of API you have. So there's two different types of APIs. You have APIs for delegated user flows, and you have APIs for applications. So if it's an API which is used from an application, it's really easy to set up an integration test then where you test from the outside and you test everything from the outside, including the security. So there's lots of examples I've seen online how people actually do that. If you're doing a delegated flow, then you have to type of make a backdoor in some type of build environment where you can allow a access token to be given to a non-delegated user, because a delegated access token should be only acquired by a user login, which means you have to give consent and some human has to actually click OK somewhere. So if you shorten that out for integration tests where you want to test everything against the API, you have to make a backdoor, and then you have to be really careful that I cannot actually use that backdoor in a production deployment. So it should be only on your development environment. So I test from the outside, including the security for the integration test against the APIs, and then you can do the whole lot down to the database and back up, or that's up to, there's different strategies as well. You can use containers as well to rebuild it. There's good tools using the ASP.NET Core backends, how to build up integration tests. I think I've seen one or two blogs not about a month ago what was about that. It's pretty easy to set up, and I'd recommend trying to have a look at those blogs and building it, but always try to include the security in the integration tests as well, I think, because then you get the claims or you get their use also in some of the API calls. Now, of course, you can go a layer down and just test against the layers. it depends. There's no correct answer to that, but I try to include as much as possible when I'm doing integration tests. So if something does go wrong, I'll find it. I just don't know what. But if it passes, I know that the whole thing is working.
Okay. You talked about SAML and OpenID. Are there any advantages to use one over the other in terms of SAML and OpenID?
I don't see any advantages from a security perspective if both are done correctly. But there's less knowledge and less development in the SAML world, I think. OpenID Connect is moving really fast forward with the new protocols, new specifications. OAuth 2 and OpenID Connect is more or less the one now because the same people writing the different specs are involved in both of these teams. And there's new RFCs and new specifications being created and made the whole time based on OAuth 2 and OpenID Connect. It's moving forward, and I think one big advantage with OpenID Connect is it's much simpler to implement and understand that compared to SAML. SAML is much harder to implement and it's XML based, and then you have a server initiated, a client initiated, and it's really hard to configure that, and you need a tool to help you configure it. And if you don't know what you're doing, you might be making a security hole, or if something does go wrong, you have to really search long and hard to find someone that actually understands it. So its complexity is the main disadvantage of SAML, I think. OpenID Connect is much simpler to implement and roll it out.
Okay, thanks. You also spoke about client to service authentication and authorization. Let's say I have multiple microservices. What is the recommendation for service to service authentication and authorization? Which OSID flow should I use?
That
And
totally
that's a good
depends.
question.
Yeah, so there's about 7 or 8 different correct answers to that. So it depends how you set up your, the API to API. So what Microsoft does, they use a thing called the on behalf of flow. So they're using delegated access tokens, which are given to the application on behalf of that user. So somewhere up the chain, you have a user interface that logged in, and it's the best way of doing this because you're reducing the amount of access. So the API 1 does not actually trust the API 2. It trusts the access token of the user which authenticated through the API 1. So you actually reduce the blast radius by using it on behalf of flow. So you're using, I always try to use a delegated access token for any downstream APIs from my API. Now, if that's not possible, if you're in any other world, you can use a grant exchange as well, which is a similar thing possible. But usually you just use a client credentials flow, which is an API to API, which means you have a full trust between the two servers, which means that API is fully trusted by your API. So anything that's allowed to do in the API with this access token, it's full trust. So you want to reduce the blast radius and maybe made less things possible. Some things I do is I never mix delegated access tokens and API access tokens, I call applications. You have to keep them separate. So I make a application API either for an app to app or a user using the app, and I keep them completely separate. And then I can actually implement my security tests and then separate them. So I try to separate what the app is being used for. I never mix delegated and application tokens ever, and then decide after that. Now I could also use certificate authentication from API, or I can use an API key as well. I try to avoid that, but all of these are okay in certain scenarios. But the main scope is try to reduce the blast radius. Only make it possible for the API from one application to do as little as possible and only what it's allowed to do in the other application. But then keep it uncomplicated because it has to be simple. If it gets complicated, it's bad anyway. And then, of course, then when I'm accessing APIs, I don't want to be saying I get the access token. I have to go to the well-known endpoints, and then I get the data. You should only do that flow once, and then the next time you just say, "Oh, I've got a valid access token. I use that again." You have to reduce the amount of network calls as well. So simplicity and blast radius would be maybe 2 keywords.
Okay, thank you. That was very helpful. One last question, Damien. Considering the applications are moving towards using more SAML or OpenID, do we see individual logins fade away, or does it still have any advantages?
I'm not quite sure what I mean. Is this the login sign-in logs? Because it doesn't matter what you're using. You see both of them are nearly in all the providers. So if you're using Entra ID or you're using Auth0, Okta, or Ping, those logs are available no matter which one you're using in their providers. Inside the applications, you'll see your interaction with it. Depending on the library you're using, you'll see more, you'll see less. I'm not sure if you understood the question correctly, though.
Yep. So if the person who asked that question, if you have any follow-up questions, do reach out to us on the community forum, and we will expand on that. But I think that should have answered that question, I'm thinking. Okay. I think it's time to wrap up. So thanks again, Damien and Dennis, our presenters for today. And thanks to all of you who joined us today and posted your questions. I would also take this opportunity to thank Camille and Emma from our events team for all their support and hard work behind the scenes. They run these webinars every month, and so I should take this opportunity to thank them. I think we have covered all of the questions, but if we didn't get time to cover any questions, we will respond to them, and we will post the recording and the Q&A on the community forum. Feel free to visit our website, sonarsource.com, to learn more information about clean SG code and some of the other topics that were answered in the Q&A chat panel. Thank you again for providing the feedback that you have shared with us, and we will look forward to seeing you all in the next webinars. Thank you. Have a good day.
Thanks.
Thank you.
Thanks, everyone.